This is Josh White with JW Math Tutoring. In today's video, I'm going to go through 10 more problems from the May 2026 Digital SAT Math exam. So let's go ahead and take a look.
But life is a dream that calculus could never predict.
Before I begin going through these May 2026 official test problem set worksheet number 2, I just want to mention a couple things. First, of course, if you like this video, please give it a thumbs up, subscribe to my channel, and sign up for notifications. Second, there'll be a link to the PDF file which has all these problems in it in the description of the video and also in the pinned comment as well. Third, make sure you check out the videos for part 1, which has 10 additional new problems if you haven't done so already. And also part 3, which is going to highlight 20 repeat problems that appeared on this May 2026 test that I have covered in previous videos, some of them multiple times. Other things to be aware of, also check out the spreadsheet file that is now available to be linked in the pinned comment, where it's basically every single problem from my official test problem set worksheets is listed in it, and it shows which ones are repeats. It has links to all the various videos, including the alternate solution videos and the repeat, problem videos and everything. And also, as you're seeing these problems, just be aware that I've tried to recreate these as best as possible based on what people have reported or people have said. So some of these problems may differ slightly from an example that you saw on the official exam if you took it in May. So just be aware of that. And I've tried to make them as realistic as possible. Some of them may have also been done as free response questions, whereas on the test they may have been multiple choice. So a multiple choice question might have additional answer or solving methods available that I'm not going to use as a free response question. So just keep that in mind as well. All right, so with all that being said, let's go ahead and get started here on May 2026 SAT Math official test problem set number 2. Okay, so the first one is this very common problem where you have basically these two right triangles with like one kind of, I saw it described frequently, it's like stacked on top of the other. And you're told the sine of this angle right here. So angle C right here, right? Sine of this is equal to that. So we know that, or sorry, not sine, what am I saying? Tangent. Sine is what you're solving for of an angle E over here. Okay, the tangent is equal to this over this. So of course we know tangents opposite over adjacent. So that means AB could be 252 and the adjacent side here, BC, could be 275. I mean, they don't have to be those specific numbers, but they're basically some multiples of those numbers. We also know EF is parallel to BC. And they want to know here, what is the value of sine E? Okay, so essentially all that's going on here is these two triangles are similar, which means their sides will be proportional. It also means that all their angles are congruent. And technically, E and C here are congruent because they are alternate interior angles formed by two parallel lines and a transversal. So what that means is basically there's the following, and there's multiple ways you could look at this. The sine of E is going to equal the sine of C. Okay, how do I find the sine of C? Well, it's opposite, which is 252, over hypotenuse. Okay, notice if you look at the answer choices, there's technically only one answer choice that has a 252 on the top. It has to be letter A. You don't even need to, at least based on these answer choices I chose, calculate the hypotenuse AC and then put that on the bottom. Okay, now I'll still show you that we can do that. Easiest way is going to be going to Desmos here. and just using regression, because I've got 252 squared plus 275 squared, and that is equal to, we'll just call it c squared. Okay, so it's 373, therefore the hypotenuse is 373, so this would go down here. So correct answer is just going to be this, 252 over 373. Okay, and that's it. Now, here's an alternate approach you could use. Again, you don't need to do this, but this I'm just going to show it to you because I don't know, maybe some people would find this an easier way to approach this or to solve it. So I would go into Desmos. First, I would make sure I'm in degree mode. And I would say, okay, tangent of angle C is equal to 252 over 275. All right, it's giving me some random answer here. But this is not, that's not the number of degrees that I'm looking for. So let me actually do it like this then. Let's do tan inverse. Okay. Here we go. Okay, so C is equal to that number, 42.50101 degrees, right? Angle E is the same as angle C. Okay? Therefore, sine E is equal to sine C. So now I can just do what's sine C equal to? Okay, well, it's some random decimal here, so you could go through the decimals and you could divide them all out and see which one it's equal to, but it should hopefully, if I click the fraction button, just give us the answer. Yep, there it is, 252 over 373. So that's an alternate way you could do this very quickly and easily in Desmos. Okay, let's look at problem number 2. This was another very common problem. So this is a problem type we've seen in a couple different forms previously. Here you had two exponential functions. They have some constants in them, a and b, and you're given some restrictions on the constants. Basically, a is greater than 1, and a is greater than b. Now, oh, they're also both positive, but I guess b is not necessarily greater than 1 in any case. It wants to know which of the following displays the min value of this function as a constant or coefficient. Okay, so the easiest way to do this is essentially just to go, I think, to go to Desmos and just graph them out and add values in and see, you know, do we see the min value there from the graph on anywhere in the function. And g of x is a, I'm just random numbers here, x plus 2, okay, and then plus b. All right, let's see. Did I write down what I chose for a and b? It looks like I did not. So let's just make a 2.1, and let's make b something smaller than at 1.4. Now, I forgot to add the constraint that x is greater than or equal to 0 to both, so let's make sure I do that. So, first of all, do they both have minimum values? Because sometimes in these functions, the exponential things don't have minimum values. And they both, appears that they both do. So there's one here. Okay, and there's another one here. So, now what I'm looking at, okay, so let's look at the red one first, top function f of x. Technically, the red point, well, okay, it's confusing that they're like putting the red point here. Okay, let's make this one blue, and let's just make this one red. There we go. So that the two things correspond with the functions that they're actually on, right? Red point, red graph, blue point, blue graph. Okay. Red function. The min value is 2.1 right here. Do I see that number anywhere as a constant or coefficient? Yes. A is equal to 2.1. That means right here there is a 2.1 in front of this parentheses, which is a coefficient. Therefore, so far, 1 matches, so it's either A or C. It cannot be this, it cannot be this. All right, let's go back. Now, for the blue one, the min value is 5.63444. Okay, do I see that number anywhere here? I mean, here at the end you have plus B, which is plus 1.4, so no. Here you have 1.42, no. Here you have A, which again is 2.1, no. So it looks like the correct answer is just going to be letter A, 1 only. Now, let's just make sure. If I make this down less than 1, notice it doesn't change, like it changes the shapes of these graphs, but this point right here is not changing, so nothing's changing for the first one. So the first one is, still yes. For the second one, okay, now we have this value. Let's get rid of this. 4.4344. But again, do I see that number anywhere here? No, it's not equal to A. No, it's not equal to B. No, it's not equal to 1.42. Therefore, this one is letter A. It's 1 only. Okay, the next problem here, number 3, is actually a very easy problem to figure out. It just basically has a lot of words in it, but there's irrelevant information that you don't need to worry about. So you have these two similar right triangles. Basically, one of them is going to look like this. And then you have WXY. Okay. Now, we know that, okay, there's a measure here, 20 degrees. Of course, we also know there's a right angle. And since they're similar, we know that all corresponding angles are congruent. So, okay, this one's also going to be 20. Now, it gives you this thing that the scale factor between the two triangles is basically 12. One side is 12 times the length of the corresponding side WXY. That's irrelevant. That has nothing to do with anything. That you basically just ignore. So what is the measure of one angle of this new triangle? Now, okay, obviously 90 degrees is a possible answer. 70 degrees is also a possible answer. And I guess technically 20 degrees, I mean, you wouldn't put in the degree symbol, but 20, I guess, would technically also be an answer based on the way I've worded it, where I've only given you an angle measure in RST. I haven't technically told you that W is 20 degrees. So if that's not excluded based on the wording, then there's technically 3 possible answers here. It's just 20, 70, and 90, and that's it. I'm guessing that the wording of an official test problem that dealt with this was a little bit different in that it was set up to exclude like 1 or more answers here, so that it was only 2 of these 3 answers would be correct, meaning one of them's already measured or mentioned in the problem. But just based on the way that I've set it up, it's 20, it's 70, it's 90. Or I guess this could be a multiple choice, and maybe only one of these is a listed possible value, and the other 3 are all different, incorrect values and everything. But that's it for this problem. Okay, next up, this is actually a repeat question that I covered once before, but I did want to go through it and highlight it once again, just because of how kind of like random a question this was, and it was I think it was 2024 for sure. When it first came up. So this is a word problem, and essentially what you're using is the equation where revenue equals like price times quantity, price of the tickets times quantity of tickets sold. And essentially what's happening is you're going to set the price equal to X, and you're going to set, oh wait, actually, sorry, no, let me just double check my work here. Number of tickets sold. No, excuse me, it's incorrect. The quantity is equal to X. Yes, X represents the quantity of tickets sold because that's what we're going to be solving for. The price is basically like it's essentially starting at 90 and then you're decreasing it by 1.5x because it goes down by $1.50 and the same point the number of tickets sold increases by 1. So that whole like minus 150 and increases by 1, that's essentially kind of like a slope. That's the number here that's going to be multiplied by x, the number of tickets. So now you know what the this 3 months, by the way, that's irrelevant. That could be whatever time period. That doesn't matter. But the revenue is what is important. So it's 1,012.50. This is equal to the price times quantity equation. So you could go ahead and multiply this whole thing out, and you could solve this by hand. I don't know why you would want to do that. I mean, I guess if you wanted to just double check your work, you could do that. But what I'm going to do is just go straight to Desmos and solve this in Desmos. So you could actually do you actually do it with regression just based on what's given here. Then there technically are 2 possible answers for this. One of them is 15. And there's also, because it's a quadratic function, there's also another one. And let me just see if I can force the thing to find it. Yeah, it's going to be 45 here. If I just put in a constraint, it'll find the second one. So either 15 or 45 would technically be correct. Now, what you could also do is if you multiply it out here, 102.50 equals 90x minus 1.5x squared. Okay, so if you do simplify this and get an actual equation, distribute it. I guess technically you don't have to distribute it, but the point is if you graph just the equation itself, there's 2 vertical lines, one at 15, one at 45. Those are going to be your 2 answer choices. And also, just the last thing, I kind of want to go through and explain this again of how, where the price function, 90 minus 1.5x, came from. So if you think about this, essentially, say the price is on the y-axis and number of tickets sold are on the x-axis, okay? At a price of $90 up here, the number of tickets sold was 0. So you have a point up here of 0, 90, right? 0 on the x-axis or on the tickets. And then what's happening is, for every decrease in 150, so it's like you go down 150, the number of tickets increases by 1, and then you go to the right 1. You go down 1.5, you go to the right 1. You go down 1.5, you go to the right 1. Down 1, blah, blah, blah. Okay, so hopefully you're starting to notice the pattern now. Therefore, you have the y-intercept or a point, and then the slope is negative 1.5x, where x is the number of tickets sold. And this would give you the specific price at any point along this line. For example, if you graphed it out, just pick an x value and plug it in, and that would tell you, okay, this is the price, total number of tickets sold. So anyways, this is just kind of a more detailed explanation. This is where this part of the equation came from for the price, basically the price function. All right, next up, let's look at number 5. This one I wasn't sure on completely. So maybe if you had this problem, you remember it, the details were a little bit different or a lot different, but still, I wanted to try to go over it because it touches on some good concepts. So here you have the hypotenuse of a right triangle shown on a graph. You're given the area of this triangle, okay, 4 root 21. which of the following is the length of one leg of the triangle? Okay, this is a complicated problem, but you can actually, but because you have Desmos, you can actually solve it without, doing all the algebra. Essentially, what I'm going to do here is I'm going to set up a system of equations with two variables and then solve it out. So the first thing you need to do is figure out how long this hypotenuse is. So if you notice, if you just count on the graph, it's 1, 2, 3, 4, 5, 6. And then here we're at 4 and we end at 12. So this part is actually 8. This is just going to be a 6, 8, 10 triangle. I mean, just measuring the triangle doesn't necessarily look like this, but I'm saying just in general to get the distance here. It's 6 squared plus 8 squared equals c squared. And this is 36 plus 64 equals c squared. C squared equals 100. C equals 10. Okay, that's the main takeaway, right? That this thing is equal to 10. Also, just to show you, we could, of course, go to Desmos, and we could just use the distance formula with, let's see, the first point appears to be 1, 2, 3, 4, and the second point appears to be 9, 12. Okay, there's our distance of 10 for our hypotenuse. That's just an alternate approach. Okay, here are the two equations you're going to set up now. I am going to just draw a generic right triangle. Like, let's say it looks like this. We don't know what it looks like, but let's just say this is side A and this is side B. These are both legs, right? One of these is actually, change my mind. Let's call this H for height and B for base. We know the following. We know that 4 root 21 is equal to 1/2 times the base times the height. So this right here is one equation. The other equation, of course, we know is Pythagorean theorem. We know that b squared plus h squared equals 100. Technically 10 squared, but I just know that's 100, so I wrote that. So this is the second equation. Now, I can go to Desmos, I can solve the system of equations, and I can get values for b and for h, and one of those two is going to equal one of these four answer choices. So let's just first try graphing it, and of course I'm going to use x and y to do that. So there's the area equation, and then the other one technically is a circle. Okay, so what do we have here? So we've got, so notice there's, first of all, the negative values we can ignore. We don't, deal with negative height or negative, triangle side lengths. So these intersections down here, just ignore those. They're irrelevant. They don't matter. We only want these two positive ones here. And notice the values are just opposites, right? It's one of them, it's 4. The other, it's 9.16515. Okay, 4 is not an answer choice. So do we have an answer choice that's equal to 9.16515? Okay, well, it's obviously not A. A is equal to 10. Get rid of that. Let's check B. Square root of 21. Nope, not it. 2 root 21. Yes, that looks like it's going to be it. 9.16515. 4 root 21, of course, is not going to equal because that's the area, and that's the half the product of them. So one of them alone is not just going to equal that. Unless I guess the other side happened to be 2 and it just completely canceled out, but that's not the case. We know the other side is 4. So therefore, it's going to be letter C here, 2 root 21. Again, if you want to see the algebra work for solving this all by hand, I have done it out on my notes here and like basically factored it and so on and so forth. I will send it to you, or I will post a link to a screenshot of it, but there's no need to spend the time here in the video just going through and working that all out. Okay, next up, there was a question about a cone that dealt with the lateral surface area of it. So the lateral surface area is basically, just the surface area of the triangular pointy part, not including the circular base, essentially. That is given also, like the base, area is given here, 81 pi. But we know the lateral surface area, okay, 243 pi. They also have to give you this formula, for lateral surface area of, it's basically the radius times the slant height times pi. And they want to know the overall height of the cone. Okay, so the overall height is here. Radius, of course, is down here. Slant height, L, is going down here. So how do we do this? Well, for lateral surface area, we can find the radius. We don't know the slant height, so we're going to have to see if we can find... I think what we're going to do is we're going to find that out from this equation and then use the radius and the slant height to get the height by using Pythagorean theorem. So we're going to start with the base area, 81 pi. That's equal to pi r squared. The pi's cancel. R squared is 81. The radius of this cone will be 9. Now that we have that, we know that 243 pi is equal to 9 times the slant height times pi. Again, the pi's cancel, divide by 9, divide by 9. Slant height is going to be equal to 243 over 9, which is 27. And now we go to the Pythagorean theorem. So we've got 9 squared plus h squared equals 27 squared. Let's see, did I do this out by hand? I did. So it's going to be 81 plus h squared equals 729. H squared equals 648. So it's the square root of 648. Which of these is that equal to? I mean, I'll just tell you it's going to be 18 root 2. However, I would not bother solving the Pythagorean theorem equation by hand. What I would do is instead, I would just get the answer and then see which thing it matches. Okay, so it's 25.45584. All right, it's not A, it's not B. Those are out. It's either C or D. So 18 square root 2, whoops. Yep, that matches. 9 square root 10, no, it doesn't match. Therefore, correct answer is going to be letter C, 18 root 2. Okay, next up, question number 7. This is one I saw listed at least once or twice, and I do want to go over it because this is again one of those trick type questions where they're trying to guide you to solve it in a certain way or a certain manner. Because if you do this by hand, what you can do for this equation is you can subtract x over 7 on both sides. And then on the left you have 12. On the right you have 12 of something minus 1 of that something, means you have 11 of that something, x over 7. And then to solve for one of it, you would just divide by 11, and that's it. X over 7 equals 12 over 11. Or if you want to put the decimal equivalent, it would be 1.091 or 1.09 or 1.090 technically if you truncate it. 1.091 if you round, 1.090 or 1.09 if you truncate it, or you can put the fraction form, of course, as well. Now, if you don't see that or don't pick up on that, that's fine. Instead, what I would do is I would literally just go to Desmos and tell Desmos to solve this for us. So I would do x1 over 7 plus 12 tilde 12 parentheses x1 over 7. Okay, notice this solved for x1, but not x1 over 7, over 7. So I would do x1 divided by 7. Here's your decimal equivalent. We already saw that number. Click the fraction thing, 12 over 11. This matches. So if you don't see the little trick that I just showed, I would not bother like getting a common denominator, or, multiplying to clear the fraction or whatever. I would just go straight to Desmos. Just solve it in Desmos, get the answer, and that's it. Okay, next. This appeared to be another very common problem. It was something where you were given the graph of a line, and you were given some points on the line, and then told that a new function is being made by basically decreasing each x coordinate point on the line by some huge number. Say, I think it was 575 is what I saw. And that allows you, and then it's asking you what is the equation of the new line after you do that. Okay? So essentially what's happening here is you are doing a shift of this graph, essentially like 575 units to the left. Okay? Because like take this point right here, 100 comma 4.7. This you're doing minus 575 on it. So now the new x coordinate would be negative 475. So now you're going to have a point, like whatever, way over here that's negative 475, 4.7. It's being shifted to the left by 575 units. All right, so there's multiple ways to do this. I mean, first of all, you could go to Desmos, and essentially what you're doing is, you're going to calculate the slope and the y-intercept, i.e. really the equation of this line. So I'm going to type in both points, and I'm going to do linear regression. Okay, so notice here I get the slope 0.027, and I get a b-value of 2. Okay, these are the values for the given line, not the new line after everything is decreased by that. So there's multiple ways that you could do this. One way is you could now graph out this function. Notice they overlap, that's what we expect. And then you could technically do a translation of this new one, and you could notice a couple things. First of all we need to do is match up the y-intercept value. So in the new one, it's just 17.525. That means the correct answer right here is D. Because these slopes are all the same. The slopes are 0.27. 0.027 for each of them. The only question is like what happens to the y-intercept value. So once we do this translation, we can easily see, well, it's 70.525, that's it. So that's one method. Alternate method in Desmos. Just go up here to your table now and put minus 575 for both of the points. Then look at the m, look at the b. Okay, it's 0.027x plus 17.525. That's it. Your answer choice is C. So regardless of which approach you want to take, you can quickly and easily do this in Desmos by using linear regression to get the slope and or the y-intercept as well. All right, top of the last page here, question number 9. Here we have another right triangle problem, or not another triangle problem, not right triangle. This one was featured once before, so I did, even though it's technically a repeat problem, I did want to highlight this, just, to basically review it, refresh it, make sure people are aware of it. It's basically the triangle inequality theorem. It's the whole idea that in a triangle, any two sides added together must be greater than the length of the third side. So that restricts how large or small sides in a triangle can be. So for example, in this triangle, that means we have 78 plus 74 must be greater than AC. Or in other words, side AC must be, and it's strictly greater than or less than, depending on whichever way you're reading it or interpreting it. So that means side AC must be less than 152 units. Now, we can also look at it as 78 plus AC is greater than 74. This doesn't matter because basically 78 is already greater than 74, so it doesn't matter what you add on to it. It's going to be positive, so like that one you can ignore. And then you have 74 plus AC is greater than 78. There's basically three different pairs of like two sides greater than the third, right? So if you solve this, you get AC must be greater than 4. So essentially here, AC is between 152 and 4. Anything in between those is acceptable. So 4.1, is that in between 4 and 152? Yes, can be. 74? Yes, can be. 78? Yes, can be. 152? No, cannot be. So that is the answer to the problem, letter D. The third side cannot be 152 because any two sides has to be greater than the third side. They cannot be equal to the measure of the third side. So the correct answer to this one is just D. All right, let's look at the last problem now. This is actually similar to a problem on one of the Blue Book practice tests, but it's not quite the same because that one involves a translation or a shift. I'm going to zoom out here just to get the whole problem on the screen. Whereas this one does not. This is just, here's the line. Basically, here's the equation for this line, which is graphed out. It wants to know what must be the values of A and B. Not specific values, but basically, do they have to be positive or negative? So there's multiple ways you could look at this. First, I'll talk theoretically. If you put this in slope-intercept form, so you get by equals negative ax plus 16, and then divide by b, divide by b, divide by b here, okay, you get the following. Notice the y-intercept of this line will be negative. It's not pictured, but it's going to be like whatever, somewhere down here, and it's going to be a negative value. That means this whole thing right here will be negative. Well, if the 16 is positive, that means this number has to be negative. This is positive on top, so it has to be negative on bottom in order for the end result of dividing them two to be negative. So therefore, right off the bat, b is less than 0. So it looks like we can cross this out and we can cross this out, right? So now the question is, what about a? Well, this line overall has a positive slope. So therefore, negative a over b must be greater than 0. Okay, let's like just work solely with the signs now. We know b is negative. We know that there's already a negative up here from subtracting the term over. So a negative divided by a negative is a positive. So these two right here cancel out and make a positive. So for this whole thing on the left to stay positive or to be greater than 0, a has to be positive as well. Therefore, the correct answer is going to be letter B. All right, now, perhaps that's the kind of like the theoretical approach. What you could also do is you could literally just go to Desmos and just type in some possibilities and see like, which of these match or look in the same general shape, both from the slope and the y-intercept value as the graph. So, for example, let me just erase all this. Okay. Answer choice A, they are, actually what I'm going to do is I'm going to put A here and B here. I'm just going to say, okay, they're both positive. Notice the slope is wrong and also the y-intercept is above the x-axis. It's positive, it's not negative. Okay, let's look at answer choice B. A stays positive and I make this negative now. Notice the slope is now positive. That matches. The y-intercept is negative. That matches. This is the correct answer. I mean, it's not the same because these aren't the right values, but my point is you're just looking to match the slope being positive versus negative and the y-intercept being negative, not positive. Then you could try, let's say you wanted to try choice C, so you make this negative and this positive. The slope is right, but the y-intercept is wrong, and if you go to check D, where you make them both negative, Here the y-intercept is right, it's negative, but the slope is wrong. So this is how you could do the problem, just visually, going through each answer choice and inspecting it in Desmos. Okay, I hope you enjoyed the solutions to this May 2026 official test problem set worksheet number 2. If you did, please do give this video a thumbs up, subscribe to my channel, and sign up for notifications. Otherwise, if you haven't done so already, check out the video for part 1 for 10 more new problems from the May 2026 Digital SAT Math section. And also video part 3, which highlights 20 repeat problems that I have covered in previous videos, going back 2 years now to May 2024 as part of my official test problem set playlist. Also, check out the spreadsheet, which has every single problem, like I said, going back to May 2024, listed in it, and including the main general area, topic area, and then also a subtopic area. It also shows which problems repeat. It has links to all the individual videos in it. So be sure to check that out as well as you're preparing for the digital SAT math section. One last thing to mention, if you're looking to improve your knowledge of Desmos, then please check out my Ultimate Desmos Guide to Digital SAT Math. There are 2 versions of it now. There's the free version, which is on my YouTube channel. Currently has over 70 practice problems. Covers all the various topics from your basic core skills up through advanced topics and the various types of regression that you can use to solve constants and the various problems you find at the end of Module 2. And then there's now also a premium version that you can purchase on Udemy. The material in both of the courses is essentially the same. The main advantages to the premium version are that it's ad-free. In other words, you don't have to bother watching ads like you would on YouTube. And I've re-recorded some sections of it and basically rearranged them, especially the advanced skills, so that the common types of problems that have multiple methods are all grouped together. So in other words, all the different methods you can use to solve for a constant in a system of linear equations are all together in one video. And all the different types of methods you can use for solving to find the value of a constant for various types of quadratic problems, are all basically grouped together in one method. So it's organized a little bit better than compared to the original, free version on YouTube, where the problems and the topics that are covered in it are basically just, chronological as I, figure them out or discover them. So in either case, please check out either of those. They're loaded with tips and tricks and basically all the practice problems and skills that you need to ace the digital SAT math section using Desmos.